Okay, so this is something I introduced in the very beginning. If you remember, first, second class, we discussed architecture, huh? And we discussed about microservices, and we discussed about containers and servers and load balancers, and we thought, and we also discussed why Kubernetes can be used. So I kind of introduced why Kubernetes has to be used and why it is actually used, what problem it solves in the world of microservices deployment or application deployment or containerized deployment, so to say, right? So I'll not go into this because it's already quite complicated. I'll try to explain it again, but I will not explain too much because Kubernetes is a complex topic, and usually people make it more complex when they try to understand each and everything in the initial stage itself. So the reason Kubernetes is complex is because the architecture of it is quite complex. The usage of Kubernetes is not that complex. How to use Kubernetes is not that complex. How to set up Kubernetes cluster and do things inside as an administrator or Kubernetes system administrator, yeah, that's complex. But the first thing when you encounter Kubernetes, and first thing to learn is what it is, how to use it, and how to deploy your application on an existing Kubernetes cluster. That is easy. Okay, so that is not tough. That is quite easy. You need to learn basics, very, very basics. What is what? And there are a handful of basics. They are not too many things to know in the beginning. So a handful of things which you need to know. And once you know those things, yeah, that's it. Right? And then you build on that knowledge slowly, gradually. Every time you try to do something more in the cluster, maybe try to set up your own cluster and this and that. All right, so that is the starting note when I'm starting Kubernetes. So I'm giving you this understanding that don't learn Kubernetes as if it's a very complicated thing. That's what has been taught, and you will hear this a lot everywhere you go, and see YouTube or wherever you see. Whenever you talk to, most of the time people say it's very complex. It is complex, but it is not complex when it comes to just using it. And first thing, the basic thing when you go and learn something, it's always first focus on how can I use this, not try to immediately try to do a PhD on the subject, right? That's not how things work. You have to go step by step. Fine. So let's start with the basic things, okay? For that, it's better I start with some diagrams because diagrams gives visualization, and we need optics. We need to see what's happening, right? The logical understanding of it. Okay. So what are we doing so far, right? Okay, well, how things used to work in the past. Let me not tell you more, all the history again. But we used to have virtual machines. In virtual machines, you will deploy an application, isn't it? You deploy application. This is your app, and then it just works. And then you access this app from outside, and the app works, right? Okay. There is one more thing called as before app. There is a server. Inside VM, you have a server like Nginx or maybe your Tomcat, right? And they reply, they accept the request, and they pass it on to the app. App does something and then replies back. So that's the setup. That's how things work. And that is actually what we learned. If you remember, this is exactly what we are trying to do in a different fashion. But essentially what we have right now is we have one EC2 instance, just one EC2 instance. And on that EC2 instance, we have deployed an Nginx server, right? And Nginx server is routing the traffic on specific path variables to the Docker instances. So we have installed a Docker environment inside the EC2 instance, and there we are running containers, and the traffic which is coming is getting routed to those containers, right? We had this Flask API there, and that's how it's doing. I don't have a running instance of it, otherwise I would have showed it again, but you know the drill. We have been doing this from past 2 weeks, right? So I don't need to show really. But that's what we are doing, and that's what we have learned. Why did we learn this? Because we want to understand the basics of it. We want to know what server is, how to do SSH, what is container, how container runs, how to stop a container, how to start a container, how to build images, all those things, right? That is the foundation of the next step. That is the deploying something on the Kubernetes cluster. Now, why do we need it? What if we want to install more, right? We want to install more containers. Right now, I had just one Flask API, one simple dumb API, which I deployed. What if I have to deploy 10 more containers? Then I have to do what? I have to do increase the power of the underlying virtual machine, isn't it? I have to increase the power of this. Right now it's micro, I think nano, one CPU, one or maybe 800 or I don't know 1 GB RAM. But then if I keep on increasing the load, the virtual machine has to be scaled up vertically. So I have to do a vertical scaling, which is not a good strategy. This part we discussed कि vertical scaling अच्छी नहीं होती है. Vertical scaling क्या होती है? That means that you have to add more and more RAM and more CPU. उसमें CPU RAM add करते जाओ ये बल्कि होती चली जाएगी then can run more, but that's a single point of failure, right? अगर एक VM गया तो गया पूरा system down. That's a worst case scenario for a disaster recovery perspective, right? So there are better approaches. Okay, so instead of giving you a lot of theory on what is what, let's jump directly into the use case, okay, or the overall structure of it. So what happens? So to solve certain problems, there are people in Google who created this product called as Kubernetes. Google created the Kubernetes and then they outsourced it. Okay, and when they outsourced it, then it immediately became a hit, and people started adopting it because it was just so nice. And the primary use case for this is called as, let me write it, it's called as container orchestration. So Kubernetes is used for container orchestration. Okay, what is container orchestration? A place where containers can run. हाँ, जो orchestra होता है ना, where a lot of people are singing and dance and music and all those things, like the group of people. So it's orchestra, right? Just giving some dumb example, stupid example, but worth it. So Kubernetes is a place where you run containers efficiently. It's a scalable solution. And then you can do hell lot of things within. You can have multiple containers, internal load balancing. So a lot of concepts in application release management, where to make it more elastic, to make it more scalable, to handle better disaster recovery, to have a better disaster recovery, and a lot of different concepts, which if you remember, we did discuss here. Something called a service discovery, elasticity, fault tolerance and recovery, automatic recovery, okay, auto scaling, load balancing, few things I wrote here. Okay, I want you guys to read about it. Okay, there's no point for me to cover each and every line again and again here, because we are doing practical learning or practical training, right? So I expect you guys to read it. Okay, I will give you, I'm recording this video, I'm going to send this, I'm going to write a lot of things also. Keep a note that when I'm giving you a jargon, a technical jargon like service discovery or load balancing, so you note it down. You say, okay, load balancing, something interesting, let's read about it. So go back and read about it. What's load balancing, so that when next time you come and I use this word load balancing, then you understand what I mean by that. Okay, so have this habit of having a copy and pen. Don't just use a mobile and then driving and then watching it, otherwise not much benefit. So try to be at a static environment, calm environment, have a copy and pen and note it down. Anyway, so these kind of things is what Kubernetes is used for. We are going to see lot of these benefits eventually when you start implementing it. Sometimes few things you won't just understand it. So अभी एकदम समझ में नहीं आएगा. But when you start using it, then maybe it would make more sense. Okay, fine. Now let me go back again at the bottom here. So orchestration, container orchestration is what Kubernetes gives you. how it is structured. Let's create a very simple vanilla diagram of how Kubernetes is structured. Okay, Kubernetes is based on top of nodes. Okay, let me make nodes. So these are the nodes. Node 1, what is node? Server. It can be your EC2 instance, it can be your Azure instance, it can be any instance, any Linux instance or whatever. Node 1, node 2, node 3, whatever. Okay, it can have any number of nodes. Node here means your machines. Okay, on top of it you have an abstraction. This abstraction is called as Kubernetes. So Kubernetes is a software, it's a tool which runs on multiple nodes. Okay, and now in these nodes there are different categorizations. So this is called as master node, and these are others. There can be one master node, there can be multiple master nodes for disaster recovery scenarios. Then you have master node, and then you have worker nodes, multiple worker nodes, and you can keep on adding that as and when the load increases. ज़्यादा container run करने हैं आपको, या ज़्यादा performant system चाहिए, तो आप run time पे you can add node and remove node from it. So all that can be facilitated by Kubernetes. Kubernetes can facilitate all that adding and removing of the nodes, right? And since if these nodes are running on AWS, then AWS can give you further automation कि वो auto scalability आप उसमें use कर लो, and then AWS can add and remove nodes based on the load, right? So AWS can help you with doing that, right? So auto scaling भी आपको यहाँ से इस तरह से मिल जाता है. अगर आप AWS पे कर रहे हो तो AWS auto scaling, adding or removing nodes. This is called as elasticity of the cloud. So cloud is considered to be very elastic. Okay, so it can add and remove. So if you are AWS, then this can increase, but Kubernetes can help you with automatically accepting a new node and then distributing the traffic. And you don't have to do all this manually. Kubernetes can be configured in such a way that new nodes can be added on demand, on the fly, and Kubernetes just handles it for you. Okay, right. What happens on top? On top of Kubernetes, container runs. Okay, so if you have a container, like this is one container, this is another container, they will just run on top of Kubernetes. So before, let's see what was there before and what was now. Before we were having a Docker installation. This was on top of a system which is EC2 node. Come on, node. Okay, and on top of it you were running containers. ऐसे ही था ना, हम यहाँ Flask की API रन कर रहे थे, Flask API, फिर हमें वो दूसरे भी रन करने थे, तो हम सब यहाँ रन कर रहे थे. ऑटोमेटिक डिप्लॉयमेंट हो रहा था हमारा GitLab से. सो हमारे पास एक GitLab का इंस्टेंस था, राइट, और उससे हम ऑटोमेटिकली यहाँ पे डिप्लॉय कर रहे थे. दिस वाज द ओल्ड केस. दिस वाज ओल्ड. ट्रेडिशनल वे लिख देता हूँ यहाँ पे, ट्रेडिशनल वे. एक्चुअली ट्रेडिशनल वे भी ये नहीं है. इट्स नॉट रियली द ट्रेडिशनल वे. नो वन डज दैट. सिंपल EC2 में तो इंस्टॉलेशन कर लेते हैं लोग, पर ऐसा कोई करता नहीं. जस्ट फॉर लर्निंग पर्पसेस आई शोड यू, बट समथिंग which works, so you can try, give it a try. So this is what we were trying, but the better way, the right way of running the container is not on top of a simple Docker installation. It is always better to orchestrate your service or API or anything inside a Kubernetes platform. Okay, so this is called as Kubernetes cluster. Okay, so this is one Kubernetes cluster जहाँ पे 3 machines हैं, एक master है, 2 node हैं, उसके ऊपर एक Kubernetes installation कर दिया है मैंने, and then I'm running containers on top of it. Container 1, container 2. Okay, any questions so far before I go forward?
सर कंटेनर हमने यहाँ पे फॉर्म किए तो डॉकर भी इंस्टॉल किया होगा ना हमने?
हाँ, good question. So Kubernetes comes with something called as Docker runtime. So Kubernetes का advantage यही है कि उसमें आपको बहुत कुछ खुद से नहीं करना है because it comes with its own thing. So Docker runtime is already installed in Kubernetes. So you don't have to install Kubernetes Dockers anywhere. आप लोग इन मशीन से इंटरेक्शन करोगे ही नहीं. Kubernetes क्या है? Kubernetes एक एब्स्ट्रैक्शन है. जैसे कि आपको टीवी चलाना है तो आपको रिमोट दिया जाता है, राइट? Why? Because remote acts as an abstraction of the TV control. So अगर आपको टीवी को कंट्रोल करना है, टीवी चलाना है, टीवी चैनल बदलने हैं, तो आपको टीवी खोल के अंदर वायर नहीं चेंज करना है. टेलीविजन कैन हैंडल द चैनल्स ऑफ इट्स ओन, बट यू हैव गिवन अ कंट्रोल की. एक रिमोट आपको मिला है. दैट्स व्हाट यू यूज अ रिमोट टू कंट्रोल द क्यूबरनेट्स, सॉरी, कंट्रोल द टेलीविजन. सेम वे यू गेट सम कॉन्फ़िगरेशन सेटअप इन Kubernetes. So Kubernetes में आपको क्या मिलता है? In the case of remote, you get config YAML files. Come on. Right? This is called as manifests. So you configure the Kubernetes cluster. So कौन सा कंटेनर रन करना है, कहाँ रन करना है, कैसे रन करना है, ये सारी information, all the information like what to do, how to run it, all the information you will get inside the, you will write inside the configuration manifest files. And you will not go and do anything here. Okay, so all of the most of the things which Kubernetes, most of the things which you want to do with nodes and everything is already managed by Kubernetes. ठीक है, सो आपको खुद से कुछ जाके इंस्टॉलेशन नहीं करना है डॉकर वगैरह का. Kubernetes comes with its own Docker runtime called as containered, something like this. Okay, so that's what it uses, and this can run your any OCI Docker image. Any image which you create can be executed using container inside Kubernetes. So Kubernetes has Docker runtime which can run your images and convert your images into containers.
Okay.
Okay, but okay, any more questions? Okay, if not, then next level up. So Kubernetes में containers ऐसे ही रन नहीं होते हैं कि आपने container रन कर दिया. उसका एक structure होता है. Structure is that on top of Kubernetes you have something called as pods. So Kubernetes runs container inside pods. देखो मैं I'm trying to do two things here. Okay, I'm trying to be very giving you a simplistic view of Kubernetes. Okay, very simple language में आपको समझाने की कोशिश कर रहा हूँ. So this will serve as a basics fundamentals for the people who are new to it also. But it's still, if you're not getting something, you ask. So and lot of details I am deliberately hiding so that you don't get confused, because my goal is to give you overall view, and then we'll see how to use it so that you don't get too much bogged down into the details. Just understand why, what aspects of it. Okay, fine. So far we have seen first thing is nodes, जिसके ऊपर रन होगा, क्योंकि कोई भी सॉफ्टवेयर मशीन्स के ऊपर रन होता है गाइस, राइट? विदाउट मशीन तो कुछ भी नहीं चलेगा. यूनिट सीपीयू और रैम, दैट्स अ फंडामेंटल बेयर मेटल चाहिए आपको. वो आपको मिलेगा AWS से. उसके ऊपर आपने Kubernetes का सॉफ्टवेयर इंस्टॉलेशन कर दिया. इंस्टॉलेशन कैसे करना है दैट वी विल नॉट सी राइट नाउ. ओके, हमने कर दिया. एज्यूम करो क्लस्टर बन गया है. देन यू हैव पॉड्स. उसके ऊपर Kubernetes पॉड्स क्रिएट करता है. पॉड्स के अंदर कंटेनर्स रन होते हैं. ट्रेडिशनली एक पॉड के अंदर एक ही कंटेनर रन होता है, बट यू कैन रन मोर कंटेनर्स, something called as init containers or sidecar containers. But don't worry about it if you don't know. We'll forget. Let's not go into detail of it. Assume one pod, one container. Then if I want to run another container, then I will spin up another pod, and then I can run another container inside it. Thick. And I can also do one more thing. One more thing is, if I think कि यार इस सर्विस पे लोड ज्यादा है, then I can launch multiple pods with the same container. So I can say मुझे C1 भी डालना है, मुझे C container जो 1 है that I want in pod here, and then I want another pod running the same container. So I'll say C1, C2, and C3. Let's say ऐसा नाम देता हूं मैं. ठीक है? Guys, are you following me? या मैं कुछ ज्यादा तेज चल रहा हूं?
नहीं सर, आ रहा समझ में.
Okay. Okay. So this can happen, right? So you have pod C1, and C2, C3. Okay. Now when you run a pod, ये जो pod है, वैसे तो ये लॉजिकल इम्प्लीमेंटेशन, राइट? लॉजिकली तो ये एक सॉफ्टवेयर के अंदर अपने आप कुछ चल रहा है, राइट? बट इसका जो क्यूबरनेटिस का जो स्ट्रक्चर है, इट विल ट्रीट इट एज अ मशीन. सो ईच पॉड अपने आप में एक मशीन की तरह ट्रीट होता है. कि पॉड अपने आप में एक वर्चुअल मशीन है, जो कि आपको पता ही है कि डॉकर क्या होता है. डॉकर भी अपने आप में एक मशीन होता है, राइट? डॉकर का जो कंटेनर है उसमें क्या है? डॉकर कंटेनर में ओएस होता है और उसमें एप्लीकेशन होती है. इन अ डॉकर कंटेनर, व्हाट इज द कंटेंट ऑफ डॉकर कंटेनर? इट्स एन ऑपरेटिंग सिस्टम इन विच एप्लीकेशन इज रैप्ड अप. एप्लीकेशन को रैप करके एक इमेज बनी हुई है. सो वो तो आपका ये तो हो गया आपका ओएस, और ये हो गया आपका एप्लीकेशन, एंड देन दिस इज रनिंग इन अ virtual machine called as pods. So pod क्या है? pod is a virtual machine on top of Kubernetes. ठीक?
सर.
yes
सर ये जो पॉड्स होते हैं ये नोड्स के अंदर ही होते हैं ना सर?
एक्चुअली तो नोड के अंदर ही होते हैं, क्योंकि सब कुछ नोड के अंदर ही चल रहा है यार,
ठीक है.
राइट? लेकिन अब मैं एक्सप्लेन कैसे करूं, राइट? एक्सप्लेन करने के लिए आई एम गिविंग ए लॉजिकल एक्सप्लेनेशन. सो ये सब कुछ तो नोड के अंदर ही चल रहा है. नथिंग इज रनिंग आउटसाइड नोड. To explain you in more logical term, base one level up, one level after, is to explain you कि Kubernetes runs on this and the pod runs on Kubernetes. This is a visual representation of what I'm trying to explain. But everything, as you said, it's right, everything runs inside a machine. So everything is running inside these machines, right? अब सेम वे देखो यहाँ मीरो कहाँ चल रहा है? मीरो मेरे मशीन पे चल रहा है, ब्राउजर में चल रहा है कि नहीं? चल तो मेरे मैक पे रहा है, जो जिसमें सीपीयू और रैम है. बट मैं क्या बोल रहा हूँ, अगर मेरा जो ये है ये मीरो पे चल रहा है, राइट? सो द वे आई एम एक्सप्लेनिंग दिस इज दैट इट्स रनिंग ऑन टॉप ऑफ ए सॉफ्टवेयर, राइट? सो दिस इज अ सॉफ्टवेयर Kubernetes, Docker runtime, pods, C1, C2. Okay, cool. I hope you guys are following me. Fine. What is the next concept here? The next concept here is of the service. It's called as service. So in Kubernetes, there is a concept called as service, and concept of service is sort of a load balancer. Okay, so if I give you example of a load balancer, so that you know what it is. ये मेरा machine 1 है, ये मेरा machine 2 है. यार, I have machine 1 and I have machine 2. अब मेरे पास इसमें भी कुछ सॉफ्टवेयर है और वही सॉफ्टवेयर M2 में भी इंस्टॉल्ड है. सेम सॉफ्टवेयर दोनों में इंस्टॉल्ड है. मुझे क्यों करना पड़ा? क्योंकि M1 पे लोड बढ़ गया था, मशीन 1 पे लोड बढ़ गया था. तो मेरे पास दो ऑप्शन थे, या तो मैं इसको आई वुड हैव वेंट ब्रॉट इट अप सेइंग कि भाई हॉरिजॉन्टल स्केलिंग करूंगा, सॉरी वर्टिकल स्केलिंग करता हूं, आई विल कीप ऑन एडिंग मोर सीपीयू एंड रैम, राइट? और next option which I had was that I will do a horizontal scaling. So I thought, okay, instead of increasing the power of one machine, why not increase the power of why not adding a new machine with the similar power? So this is called as horizontal scaling. This is called as vertical scaling. So in this case, I did not increase the size of M1. I kept increasing the machine. और पावर बढ़ गया, M3 कर दिया. दिस इज मोर स्केलेबल सोल्यूशन. बट इससे मुझे एक प्रॉब्लम आ गया, क्योंकि एवरी मशीन हैज एन आईपी. सो प्रीवियसली ऑल द एंड कस्टमर, which is, let's say, can I insert a human here? Wait, I'm missing a dev representation, developer image. Okay, okay, इसको डालता हूँ. This looks like a dev with a coffee. Okay, ये मेरा dev है. Okay, so the dev is this person, and then let's say a person who is the client, huh? So this is the client. ये client है, okay? The client is the one who accesses the application. Let's say he's trying to access your application from here to here. Okay. Now, previously it was working because he was directly accessing its DNS or IP address. This machine's IP address, he was able to access the application. But now it's not the case because now application running on 3 places. So how this will know that it has different IP, this is a different IP, this is a third different IP. So how will he know where to go, and how will I go and divide the load, because मैंने machine डाले इसलिए थे so that I could distribute the load. So instead of now doing this, if I go and add more machines, I will place another component here called as load balancer. And now load balancer will have an IP, and the front end person will go ahead and only access load balancer. And the functionality of load balancer is that load balancer will automatically redirect the traffic. So पहला वो इस पे भेजेगा, दूसरा रिक्वेस्ट पे भेजेगा, तीसरा रिक्वेस्ट पे भेजेगा, फिर चौथा आएगा वो इस पे भेजेगा, पांचवा इस पे, सिक्स्थ इस पे, सेवेंथ हियर, एट्थ हियर, नाइन्थ हियर. So it will distribute the load. Right? So this is the concept of a load balancer, that only one component will be exposed to the front person, and then this will be accessed. And it will, the job of load balancer is to divide the load across different machines. Why I'm explaining you this? I'm explaining you this because I want to explain you this. The concept of service is exactly similar to a load balancer. It's not a load balancer, but it acts as a load balancer. Okay, what it does, it distributes the traffic coming from some other component and distributes it evenly to the pods. So if there are 2 pods running the same container, that means they have the same label, same selector, then whatever traffic coming here for container 1 will always come here first, and then the request will be transferred to this pod in a round robin fashion. This is called as round robin. The round robin here means it will go in a round robin fashion, distribute the load in the round robin manner. Okay, that means it will distribute it based on 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. So 1, 2, 3, next request 4, 5, 6, 7, 8, 9, like this. So we'll try to evenly distribute it. You can configure that also if you want a different approach, but that's the default behavior. Same thing will happen here. Service 1 here. So one service represents one type of pod, not multiple. So if I go here, so I'll say service here. Okay, this is, let's say, service 1. This is my service 2. This will route traffic here, and this will route traffic here. Okay, and all of them will have a IP address. So it's the services which have IP address. So service IP1. What the hell? IP1, IP2, IP3. IP1, IP2, IP3. ठीक है. IP का biggest problem क्या है? Can anyone tell me? Can anyone tell me what is the problem with IP?
It's change if the pod goes down.
Yes. IP is not constant. IP changes. If service is deleted, it's not pod, by the way, it's service. Service is deleted. Pod is very, very ephemeral. That means pod can go away and come back. Nothing changes. The service. If service is changed, IP is changed. Okay. To solve this, Kubernetes has a solution. Kubernetes go ahead and add a DNS name. It gives IP, but it also gives a DNS name to the service. Okay, so now you have not only IP, you have DNS. What is DNS used for? It's used for identifying the pod. So for example, imagine this pod wants to reach to this pod, है ना? जैसे मैंने डॉक्टर ये एप्लीकेशन बताई थी आपको, right? There was an application here, Doctor Everywhere reference application. There were 3 APIs in this one. One was appointments API, one was doctor API, third was patient API, and then you have Vue.js front end application. Now, if I try to simulate this here, imagine, can I draw this? Okay, so let's imagine this is your front end. This is your front end pod. So let's say you have 2 front end pods. One is this and second is this. ठीक है, ये exactly same pattern है जो मैंने यहाँ बताया, ये वाला. हाँ, because यहाँ पे 2-3 machine लगी हुई हैं. Here also you have 2 machines because pod, imagine, visualize pod as a machine where your container is running. So I have 2 pods, front end, 2 pods, so that the load can be distributed evenly. Okay. To access this pod, I have one DNS. DNS name, let's say, is UI. So मैंने इसको ऐसा लिख दिया HTTP UI. This is my, let's say, DNS for this name. To access this, I will simply say HTTP UI. Okay, that's my actually DNS for this. ऐसा मैं यहाँ पे कर
Akash sir, I have a question here. So, the DNS is to access the pod or is to access the service?
Service.
I mean, the load balancer.
Service, yes. Service is how you reach a pod. You don't reach a pod by any way.
Okay.
Service is what you access, not the pod directly.
Right.
So very similar to here. Huh? ये कोई भी हो सकता है. The client can be a developer on internet, or it can be another pod. It can be another machine, for example. M4 is trying to reach. Now M4 want to reach this these machines. It will not directly reach it. No. Okay, it will not directly reach it. Okay, it has to go via load balancer. Okay, same way here, if service 2 wants to reach to service 1, it will not go directly. Okay, it will not go directly. ऐसा नहीं जाएगा वो. No. Okay, everything has to go from service. So if this wants to go to service, reach this pod, it will go like this. Okay. Okay, fine. Now this is UI, and iska, let's say, let me give it a name as let's say this service का नाम मैंने रख दिया है patient API. So this became my patient API. Okay, and then this is my doctor API. Doctor API. Okay, so this is my HTTP UI service. This is my patient API. This is my doctor API. So if UI wants to access patient API, it will go. यार रबर नहीं है क्या, इसको हटाता हूँ यार. It's destroying the diagram. Okay. Oh, okay. Okay, so okay, so if this service, ये front end है, front end मैंने आपको example दिखाया था इसका. Front end goes to and try to reach out to the backend API, right? So इसके अंदर, इस application के अंदर, I have to define how to find service 2. So I have to define saying, if you want to reach service 2 or patient API, write HTTP patient API. Don't call it by its IP, call it by its service. So this is the use of service. Okay, it will use this inside and use it. Okay, same thing. If you want to reach out here, it will call this.
सर एपीआई
call the server.
चेंज होते तो डीएनएस नहीं चेंज होता क्या?
API
हेलो
change कैसे, मतलब कैसे API change?
सर, जैसे हम कंटेनर को रोक देते हैं तो एपीआई
हाँ
चेंज हो जाता है हर बार, तो डीएनएस नहीं होता है क्या चेंज?
नहीं, सर्विस देखो, सर्विस will remain as it is. If you're not tinkering with service, service will remain as it is. If you are deploying a new version of a pod, right, then you say I want to deploy a new version of the pod, then also service will remain same. The pod version will change, the container running inside the pod will change. So let's say I'm right now running version 123 of Docker, right? I'll say I'm running this, fine. Next day you say no, I want to run a new version. So you'll say change the version of the pod 568. Then it will change it, but service will still direct it to the new pod. This will remain same.
नहीं सर, मैं आईपी का पूछ रहा था कि आईपी जैसे हम सर्विस बंद करते तो आईपी चेंज हो जाती है,
Yes.
तो डीएनएस नहीं चेंज होता है क्या?
नहीं, DNS तो नाम है ना, वो
अच्छा,
नया उसी नाम पे नया, जब नया सर्विस बनाओगे तो नेक्स्ट टाइम बनाओगे तो IP will go and associate with the same thing.
ओके,
So this is called as service discovery, right? This concept of service is a solution to a microservice architecture pattern problem called as service discovery. सर्विस डिस्कवरी का मतलब ये है कि इस पॉड को कैसे पता चलेगा कि ये सर्विस का आईपी का है. यही तो सर्विस डिस्कवरी का प्रॉब्लम था, राइट? इफ you have noticed or maybe you have understood, last time I was telling exactly this problem here, service discovery. कि ये UI, ये आर्किटेक्चर है, माइक्रोसॉफ्ट आर्किटेक्चर है, UI है, कंपोनेंट 1, कंपोनेंट 2, DB, कंपोनेंट 3, सबके अलग अलग आईपी एड्रेस हैं. Now component 1, how would component 1 know what is the IP address of component 3? Right? This was the problem. This is called a service discovery problem. तो उसका एक पैटर्न सोल्यूशन ये है कि एक अलग कंपोनेंट बनाओ, दिस इज कॉल्ड ए सर्विस डिस्कवरी कंपोनेंट. दिस इन स्प्रिंग बूट दिस ए कॉन्सेप्ट कॉल्ड एज यूरेका. ऐसे बहुत सारे कंपोनेंट्स ऑलरेडी आए हुए हैं मार्केट में हैं. बिफोर Kubernetes came into picture, these service components were already there called as service discovery, और वो सारे components के IP को स्टोर करते थे और उसकी DNS से मैप करते थे. And that's how everyone would know without worrying about IP address. So this was the solution, right? But with Kubernetes, this problem is solved. So solution, service discovery component store IP for all the single location. At single location, store IP for all at the single location. राइट? आईपी स्टोर करके उसके अगेंस्ट में वो डीएनएस एक की डाल देता है, राइट? दैट्स फॉर सर्विस डिस्कवरी टू. दैट्स आल्सो Kubernetes too. So Kubernetes has service discovery implementation in the format of service. ये सर्विस का जो कॉन्सेप्ट है, इसका मेन ऑब्जेक्टिव इज टू इंप्लीमेंट सर्विस डिस्कवरी, टू सॉल्व सर्विस डिस्कवरी प्रॉब्लम. ओके सर? ओके. Let me make it a bit bigger, smaller. Sorry, bigger, smaller. Okay. Fine, cool. So far so good, guys. Today I'll spend in building a foundation. Okay, maybe I'll show you some commands in a short while, but primarily foundation. Okay. So services so far so good, right? Everyone understood services, what services is doing and what are we solving?
Yes, sir.
Okay. Next thing, there are three kinds of IP address, the three kind of service which you have here. Okay, now we are jumping one step ahead. Those three kinds are, one is called as node port, second is called as, okay, let's start with first one. The first is cluster IP, and second is called as node port. Okay, let's keep it simple. Let's say we have only these two, cluster IP, node port. Cluster IP is whatever IP you see here, they are all the examples of cluster IP. Okay, this is all the cluster IP. So automatically what Kubernetes does, it gives the IP address to the services. So each service will have a IP, and that IP is a virtual IP, and that virtual IP is called as cluster IP. When I say cluster IP, as name suggests, it means it is a cluster IP. That means it's only can be accessible within the cluster. So एक cluster के अंदर ही उसको access किया जा सकता है, बाहर से नहीं कर सकते. So service 1 can find service 2, service 2 can find service 3, service 3 can find service 1, Service 1 can find service 3. But if there is something running here, right? Let's say it's you. Okay, let's say it's developer. So this is a developer, and this is a, okay, no, this is a developer, and this is a customer. Okay. Now, अब आपको फ्रंट एंड एप्लीकेशन यूज करनी है. फॉर एग्जाम्पल, यू आर अ डेवलपर. अच्छा, आप डेवलपर नहीं बोलो, अभी आप कस्टमर हो. You are a customer and you want to access service 1 because front end चलाना है आपको. You have to want to access the application. If you want to do this, then you will not be able to do it. Why? Because it's cluster IP. It's not allowed to access from outside. Okay, so you cannot do that. So this is not allowed. What is the solution? There are many, not many. There are three, four solutions available. One solution is node port. Node port solution. In node port solution, what happen is ये जो node है ना.
Akash sir, sorry to
Yeah.
interrupt you, but I missed on the part like why these IPs are called as cluster IP.
Okay, we call this as cluster IP because what is the cluster? ये जो पूरा setup आपको दिख रहा है ना, all this setup,
Yes.
whole setup, this is the cluster.
Okay.
Okay, so इस cluster के अंदर जो भी है, उसको जो भी component है, उसको एक IP मिलेगा जिसको हम cluster IP कहते हैं. Cluster IP also mean that it can only be accessible from the within the cluster. इस within the cluster में क्या क्या है? 1 2 3 है. जैसे आपका हाउस है, उसमें 5 लोग रहते हैं. दे आर ऑल पार्ट ऑफ द सेम हाउस एंड दे कैन फाइंड ईच अदर्स लोकेशन कि ये वो इस कोने में रहता है, ये उस कोने में रहता है, वो इस कोने में रहता है. बट समवन आउटसाइड द क्लस्टर, आउटसाइड द हाउस may not know and cannot know. Okay, so that's the concept of networking because Kubernetes also gives you mechanism to provide the networking. So networking में ये firewall rules होते हैं जिसकी वजह से you cannot access any of the service from outside. आउटसाइड मतलब क्लस्टर से बाहर, इंटरनेट से या कहीं से भी, इससे बाहर आपको एक्सेस नहीं करने को मिलेगा ये सर्विसेज को. इसका आईपी होगा, आप करोगे आई 1235 से व्हाटएवर .8080, नो, ब्राउजर कैन नॉट एक्सेस, वो करने नहीं देगा आपको. ओके, सो क्लस्टर आईपी को मैं कैसे एक्सपोज करूं? दैट्स द प्रॉब्लम बिकॉज मुझे चलो सर्विस 2 एक्सपोज नहीं करनी, सर्विस 3 एक्सपोज नहीं करनी, पर फ्रंट एंड तो करना है, राइट? फ्रंट एंड नहीं करूंगा तो एप्लीकेशन को चलाएंगे कैसे लोग? So I want to expose front end, right? So that means it's a valid use case. So what is the solution? अच्छा, ये हमने किया क्यों है? Kubernetes ने इसलिए किया है because Kubernetes comes with a security inbuilt. Kubernetes का कहना है everything is secure. अगर सर्वर में रन हो रहा है तो by default मैं उसको cluster IP दूंगा. मैं by default कुछ और नहीं दूंगा. आप बोलोगे तो मैं दूंगा, पर अगर बोलो cluster IP तो मैं cluster IP दूंगा. That means no one else can then access it except विद इन द सर्विस. क्योंकि ये सर्विस मुझे एक्सपोज क्यों करनी है? डॉक्टर एपीआई मुझे क्यों एक्सपोज करनी है? वो तो फ्रंट एंड को कॉल करना है ना. मेरा फ्रंट ऑफिस विल नेवर, मेरा फ्रंट एप्लीकेशन और मेरा यूजर विल नेवर गो एंड कॉल. अब आप अमेजोन चलाते हो तो अमेजोन की एपीआई थोड़ी ना कॉल करते हो. यू कॉल अमेजोन फ्रॉम ए वेब ब्राउजर, राइट? सो नो वन विल नीड टू एक्सेस द सर्विसेज. द कस्टमर विल नॉट हैव टू. सर्विसेज के जो क्लस्टर आईपी, सर्विस के जो IP type है, it should be cluster IP always, because then you don't want to expose it to the end customer, right? But if you do want to, let's say आपको ऐसी front end application है which is actually have to call the service, then you may have to expose it also, right? So there are different use cases for when to use cluster IP and when to use something else, right? So by default, try to make everything cluster IP because that's the safest. Okay. First thing is node port. What is node port? The node port is जब मैं किसी सर्विस को node port IP assign करता हूँ, so what happen is हर नोड पे एक पोर्ट allocate हो जाता है. Every node will have a port allocated something. अरे यार, ऐसा. ओके, तो इस नोड के पास एक पोर्ट एलोकेट हो जाता है, एंड जब भी आई एम ट्राइंग टू एक्सेस अ सर्विस, द ट्रैफिक देन रीराउट्स मी टू these ports, and this node port will then redirect me to the service. Okay, इसका एक एग्जांपल और है मेरे पास, somewhere I had it. Let me see which can explain this a bit better. Can this be the good example? नोड पोर्ट, हाँ देखो ये बस अच्छा डायग्राम मिला है मुझे, इसको मैं यहाँ चिपकाता हूँ. ओके ओके, ये देखो ये नोड पोर्ट का एग्जांपल है. इसमें क्या है, ये नोड है, नोड 1, नोड 2, then you have pods running inside it, and then there are service, and then this service is of type node port. Service का type node port है. So what will happen is when the external client will try to access the service, it will come to the node का port. Node port मतलब node का port, right? So node port, and the node port then will directly automatically transfer the traffic to service, and service will then internally transfer the traffic to the pods running inside these machines. Okay, so in this example you have same pod running in two nodes. तो एक नोड में ये pod चल रहा है, दूसरे नोड में दो pod चल रहे हैं, पर तीन pod चल रहे हैं. Same example which is this one. So let's imagine this is pod 1, pod 2, and then pod 3 also. One node is running here, two nodes are running here. But typically you don't have to worry about कि मेरे किस नोड पे कौन सा pod चल रहा है. Kubernetes automatically handles it for you. So don't worry too much about that. But this is how node port works. Okay. Okay. Next best way, actually the best way is another example. मेरे पास बहुत सारे example diagram मिल गए मुझे. Wow. Let me put that also here. ये देखो load balancer. Okay. So here there was example of node port. Then there was cluster IP. So cluster IP is for internal. Different ways of accessing is either via node port. Second example was of load balancing. And then let me tell you a few more. So maybe using port forward, but this is just for debugging. And then one more is for, which is actually the mostly used, is the ingress, which is let's say Nginx controller. इसलिए मैं आपको Nginx पढ़ा रहा था ताकि आपको थोड़ा Nginx का आइडिया हो. That's what we will be using. Okay, load balancing. I tried explaining you load balancing here so that I'll introduce it like this so that you understand what it's doing. So यहाँ पे भी मैं यही कर रहा था, right? Right? If you remember, this is what I was doing also. Load balancer. I want to route traffic to multiple machines, so I put a load balancer on top. Okay, so one for end customer, he's only accessing here, but then load balancer will decide where to route the traffic. Same thing can happen here. So external client will come, it will always reach load balancer, and then load balancer will route the traffic to the node port, and then node port will then route the traffic to service. Okay, इस केस में प्रॉब्लम क्या था? इन दिस केस इसका आईपी यूज करूं कि इसका आईपी यूज करूं, ये एक्सटर्नल क्लाइंट को कैसे पता चलेगा? अगर 10 नोड हैं तो वो कैसे पता चलेगा? वो उसको सारे याद रखने पड़ेंगे. हालांकि रेस्पेक्टिव ऑफ किसी भी आप नोड के आईपी को यूज करोगे, ये नोड 1 का आईपी, ये नोड 1 का आईपी है, नोड 2 का आईपी है. अगर आप इसको यूज करोगे तो भी वो सर्विस पे जाएगा, इसका करोगे तो भी सर्विस पे जाएगा. पर अगर 10 आईपी है तो कैसे डिसाइड करोगे, राइट? So that's the reason the better approach of, instead of node port, you use load balancer. So you put a load balancer and there you expose the load balancer जिसका IP हमेशा fix रहेगा और traffic हमेशा इस पर आएगा, and this internally will decide round robin fashion में कि यहाँ भेजो कि यहाँ भेजो, क्योंकि कहीं भी भेजेगा जाएगा तो सर्विस पे ही. The service is shared across nodes, तो जाना तो सर्विस पे ही है. ठीक है, so that's another way of doing it. ठीक है, अब मैं थोड़ा रुक जाता हूँ. ओके, मुझे ऐसा लग रहा है कि बाउंस होने लगा है अभी. ओके, Nginx अभी नहीं बात करता मैं. ठीक है, let's wait for it. Let's see, maybe next coming sessions we start with this, because this is something which is what is actually being used. This and load balancing, these are what two approaches primarily being used. Okay, load balancer. Port forward we will also use a lot, but only for debugging. So port forward anyway, I will show you. Okay, I will take a pause and I'll give you like a 1 minute to think of questions, concerns, problems, whatever comes to your mind. You can put in chat, you can speak.
सर
Yes.
सर पर इसमें मतलब जो क्लस्टर रहेगा क्लस्टर आईपी तो उसको कैसे पता चलेगा इसको सर्विस 1 पे ही जाना है या फिर सर्विस 2 पे ही जाना है करके, क्योंकि क्लस्टर
क्लस्टर
आईपी तो
आईपी
हाँ जैसे कि
क्लस्टर आईपी, हाँ बोलो बोलो, सॉरी।
एक क्लस्टर आईपी में मल्टीपल सर्विसेज है, राइट? सर्विस 1, सर्विस 2 और सर्विस 3।
Cluster IP is just one service. This is cluster IP2, this is cluster IP3. They all have different IPs, not the same IP. This is cluster IP1, this is cluster IP2, this is cluster IP3. ये जो IP मैं पहले बोला था ये cluster IP है।
तो फिर सर क्लाइंट को कैसे पता, क्योंकि इसका तो कोई भी एक सर्वर पे रहेगा ना, तो फिर इसको कैसे पता चला कि तू मतलब
इसको
हाँ
इसको जरूरत नहीं ना।
अगर
he doesn't need to know cluster IP. He only needs to know the one IP. That one IP I am giving you in two ways. One IP, either this IP or this IP, or this or load balancer का IP. So the client, this external client, right? The external client don't have to worry about इस सर्विस का IP क्या है। जो क्लस्टर IP है वो सर्विस का IP है। Cluster IP जो is there for service. Okay, so if I put it like this here, this is your cluster IP of the service, for example. Okay, client doesn't need to know this. Client, I have configured the node port, right? So node port will go and this is the node port basically, node ka IP. So then this will always call this, and this internally will do something and redirect the traffic to service, because service का जो type है वो मैंने node type कर रखा है। Type of this service is node port. Okay, I think I should also show some examples if I
सर
can.
वन थिंग इज आल्सो
Yeah.
सर अगर सर एक मिनट वो ऊपर की डायग्राम देखो ना, यूआई वाली जो डायग्राम है। फॉर एग्जांपल एक ये है, इसने पहले अंदर यूआई की आईपी एक्सेस किया। फिर अगर यूआई को डायरेक्टली फॉर एग्जांपल एंड यूजर को डॉक्टर अपॉइंटमेंट लेना है, डॉक्टर एपीआई के अपॉइंटमेंट फॉर एग्जांपल,
ठीक है,
तो फिर यूआई थ्रू ही उसको डॉक्टर एपीआई के पास जाना पड़ेगा ना?
करेक्ट,
राइट। बट ये तो कनेक्टेड नहीं है, क्योंकि ये क्लस्टर मतलब ये एक आईपी पे चल रहा है और डॉक्टर आईपी सेकंड अनदर आईपी पे चल रहा है, तो फिर इनका कनेक्शन कैसे हो सकता है ये?
ओके, सो इंटरनली दिस पॉड इज अवेयर अबाउट दिस, अंदर तो पता है ना उसको।
हाँ,
सो अंदर तो उसको पता है, मैंने अंदर रिजॉल्व कर लेगा वो उस फॉर एग्जांपल दिस इस आईपी को कॉल करना है। फॉर एग्जांपल दिस आईपी वांट्स टू कॉल दिस आईपी, वेयर इज दिस आईपी इज हियर, वेयर इज सॉरी वेयर इज दिस एपीआई, दिस इज डॉक्टर एपीआई, दिस इज पेशेंट एपीआई, है ना, देयर इज वन मोर, लेट्स से अपॉइंटमेंट एपीआई। सो अपॉइंटमेंट एपीआई नोज वेयर टू फाइंड द डॉक्टर एपीआई। सो अपॉइंटमेंट एपीआई को पता है कि डॉक्टर एपीआई कहाँ है ऑन एचटीटीपी डॉकर हाइफन एपीआई। तो आईपी उसको तब भी यूज नहीं करना है, उसको तो सर्विस का नाम यूज करना है, डीएनएस। So when the API wants to call, when patient API wants to call doctor API from here, it will call HTTP doctor API here, and this will go and redirect to this service and come here. Request will come here, it will respond, it will go back to here as a response. So this thing is only for the front. अगर आपको front से expose करना है something, then you have to do this.
ओके, तो फिर ये इंटरनल में भी ये कस्टमर एक दूसरे को कनेक्ट रहते हैं क्या सर?
Yes, because inside the same connect in the sense what they are running here, right? And they are देखो दो पार्ट है, कनेक्ट अपने आप कुछ कनेक्ट नहीं है, राइट? जब तक कॉल नहीं करोगे there is no connection, right? This is the concept of RESTful API. I ask you guys to read that also, but the concept of a container is you have to request. So when you request, the connection is established. अब request करोगे कैसे? You have to know the where, how to find it, right? Request कैसे करोगे, नहीं तो नहीं कर पाओगे, right? So how to find it is using the name of the service. So if this wants to call this, then it will go and call this at this address. This is the address pod C3 knows about this location. Make sense?
सर फिर भी नहीं समझ रहा, क्योंकि सर देखो ना, मैंने तो सिर्फ यूपीआई में कनेक्ट किया, राइट?
क्या किया?
मैंने यूजर ने यूपीआई यूआई को कनेक्ट किया,
फाइन।
ठीक है, लेकिन अगर ये यूआई को जो 2 क्लस्टर पे उसको जाना होगा, मतलब इंटरनली, तो वो कैसे जाएगा, वो समझ में नहीं आ रहा। मतलब जैसे अभी एक पेशेंट है, ठीक है, उसकी एक अपॉइंटमेंट होगी, सेकंड अपॉइंटमेंट उसको फिर से इधर आना है, मतलब डॉक्टर के पास जाना है फॉर नेक्स्ट अपॉइंटमेंट के लिए।
हाँ।
तो फिर वो डायरेक्ट यूआई थ्रू ही जाएगा कि वो डायरेक्ट डॉक्टर के पास जाएगा? क्योंकि अगर उसको डॉक्टर के पास जाना है तो पहले उसको अपॉइंटमेंट लेना पड़ेगा। अपॉइंटमेंट लेने के लिए उसको यूआई के
अपॉइंटमेंट कहाँ
पास
से
जाना
लेगा? हमेशा ये तो हमेशा
यहाँ से।
यूआई से ही बात करेगा ना।
हाँ।
दिस विल ऑलवेज इंटरेक्ट विद यूआई, राइट? सो वो
हाँ।
उसको को मतलब ही नहीं है एपीआई से।
ओके।
ही इज अनअवेयर अबाउट द एपीआई। एपीआई का कोई मतलब ही नहीं यहाँ पे। ये आपको दिख रहा है फ्रंट। आपको जब amazon.com में खोलता हूँ, व्हेन आई से amazon.in, डू यू सी
हाँ।
एनीथिंग? क्या अंदर कॉल
ओके।
हुआ? यू गो टू इंस्पेक्ट, यू गो टू नेटवर्क, मे बी देन यू कैन सी कौन सी एपीआईज कॉल हुई हैं। इतना कुछ कॉल हुआ बैकएंड पे, राइट? फ्रॉम हियर यू कैन सी व्हाट इज बीइंग कॉल्ड। ये सब कॉल हुआ, देखो ये एक कॉल यूआई कोई कॉल हुआ, ये कुछ और कॉल हुआ, ये सब अलग अलग सर्विसेज कॉल हो रही हैं यहाँ वहां से, ठीक है? फिर ये सर्विसेज अंदर कुछ और सर्विसेज को कॉल कर रही होंगी, वो तो एक्सपोज भी नहीं है, वो तो यहाँ से दिख भी नहीं रहा है। यहाँ तो केवल वही दिखता है जो यूआई कॉल कर रहा है, राइट? सो यू विल ओनली सी व्हाट यूआई इज कॉलिंग, may only from here, from the network, but then this service is calling what services, वो आपको UI पे नहीं दिखेगा, वो internal functionality है, राइट? सो अंदर का मैं आपको बता रहा हूँ, जब सर्विस 2 और सर्विस 3 को आपस में बात करनी है, देखो सर्विस UI आपने इवेंट ट्रिगर किया, मुझे कुछ चाहिए, कुछ भी, वो इवेंट गया UI पे, ओके? UI ने वो इवेंट भेजा सर्विस 2 को इंटरनली, ओके? मे बी देन सर्विस 2 ने सर्विस 3 को भेजा इंटरनली, सर्विस ने सर्विस 4 को भेजा इंटरनली, वो उसका इससे कोई कंसर्न नहीं है। फिर सर्विस 4 ने रिप्लाई किया सर्विस 3 को, सर्विस ने रिप्लाई किया सर्विस 2 को, सर्विस ने रिप्लाई किया यूआई को, देन यूआई ने रिजल्ट भेज दिया। तो इसका इनसे कोई मतलब ही नहीं है, कनेक्शन ही नहीं है। ओके, it may not come very easy, maybe you're still not able to get it, but I think that it may mean that you need to do some hands on, थोड़ा प्रैक्टिस करेंगे जब हम इसका, देन यू विल गेट इट। हम इस हमारा जो एप्लीकेशन है ना, ये इसी पैटर्न पे बना है। ये फ्रंट है, ये हमारे 3 एपीआईज हैं, और मैं आपको यही डिप्लॉय करके दिखाऊंगा। देन वी विल इन्वेस्टिगेट कि कैसे यूआई कहाँ से एपीआई को कॉल कर रहा है। विल सी एग्जैक्टली द सेम थिंग व्हाट यू आर आस्किंग, स्टेप बाय स्टेप।
ओके सर।
Doctor everywhere reference app. Can I run a Docker compose very quickly? Okay, questions guys, more questions. सब आगे समझ में सबको? Everyone got it? Clear है? or okay, tell me, like it's complicated. What are your feelings about it? It's complicated, yeah. It's okay, okay-ish. Yeah, very scary stuff. Hmm? So I'm running this application to show you some glimpse of what I want to say here. Let's see if I can show you very quickly. I also ask you guys to run this, right, as an assignment. I wanted you guys to go through this to see how this is working. So if I go localhost, this is my application running appointment doctor patient front end is running on 84 local host 84. Okay, this is my application. I say create appointment, or when I say get appointment, I go to get list of appointments. So here, because this is, here I'm calling an API. So I have architected this in a way so that the front office now calls this list of appointments. Okay. So if I go in the network, I call get list of appointments, I get course error. Wow, I think there's some bug somewhere. I have to fix it, but it's giving me course. It's hitting 8081 on appointment. That's too bad. Can I fix it quickly? Why there is a course here? Appointment app. So is this also course? Okay, I should have set this here also, which I did not. Okay, so that's the reason I'm getting this. Anyway, if I say get doctors, can I close it? Okay, inspect. I say network, get list of doctors, it's pending, and boom, the request came. So it went, you see the request URL is localhost 8082 because that's what I have placed inside of the UI application. So this has to be exposed because the UI is calling it, and actually not the UI which is calling it, it's actually the browser which is calling it. But if doctor is trying to access the patient API, that information you will not see here. Okay, so that is what I'm trying to say. So if the UI is calling the doctor API, fine, then this has to be exposed as well because the browser on his machine is trying to access this. So maybe I will put this inside behind a load balancer or a node port. But if service 2, which is let's say doctor API, is trying to call this, then I don't need to expose this because this is internal and this can reach it. This API can reach this API. So I don't have to expose this. I only have to expose this because this is being called from here like this. Okay, so there are some fundamental guys. If you're not really getting what I'm trying to explain you, you will get it shortly, but you have to do a lot of hands-on. That's what we are trying to do. Okay, so here all that information which you're seeing here has been pushed, or sorry, this has been returned by this API, which is running on at this location. Okay, my create appointment is not working, otherwise I would have showed some more example. So here if I go and let's say I give some weird name here. So the what I have implemented in create new appointment is the new appointment will only be created if the patient and the doctor already exist in the system. If patient doctor doesn't exist, then appointment cannot be created. That means when I click on create new appointment, the new appointment API will internally call get patient and it will internally call get doctor. So new appointment API automatically find it within the cluster. I don't have to expose it. This is what I'm trying to explain as a response of the question which you just asked. क्या expose करना है क्या नहीं expose करना है depend करता है. अगर मुझे सर्विस, अगर मेरा क्लाइंट इसको कॉल करना चाहता है या उसको जरूरत है इसको कॉल करने की, तो मुझे एक्सपोज करना पड़ेगा. दैट मीन्स आई कैन नॉट stay with cluster IP only. I have to put it in beside load balancer or node port. But if this service does not need to be exposed, is not being called from outside, then जैसे ये सर्विस लेट से बाहर से कॉल नहीं हो रही है, सो मुझे इसको एक्सपोज करने की कोई जरूरत नहीं है. Okay, fine. If no further question, let me give you a small demo maybe. Acha, how to practice Kubernetes, right? Okay, so there are 3 ways which you can use to learn Kubernetes on your local machine. The easiest is called as Minikube, which I think most of you already know. The second best is Kind. Kind is called as Kubernetes in Docker, Kind, Kind. That means it uses Docker and installed multi-node cluster as Docker machines. So the difference between Minikube is Minikube में केवल single node होता है, एक ही node होता है, उसी में आप सब कुछ करते हो, अपने आप उसी में run होता है सब कुछ. Kind का advantage है, it gives you a feeling of multiple nodes. So it's Kubernetes in Docker, Kind cluster. उसमें multiple machines आप बना सकते हो as a Docker machines. Third is called as micro K8s. This is like more of a Linux way of doing it. So you can try using all three. I will try to use a simple version of it, which is Minikube. Okay. So Minikube automatic. So when you install Docker Desktop on your Minikube has to run on local machine. So अगर आपके पास machine नहीं है, I think few of you raised concern that your machine configuration is so low that it can't even run Docker, because to run Minikube you need at least 2 GB, 3 GB of RAM to give it, and then 2 GB of. So Docker Desktop works well when you give 4 GB RAM to it. Otherwise it will be very slow, or it may not work at all. So if you have low configuration system, that you have to rely on EC2 instance, and there you can use Minikube and these things. Okay, so Minikube. So how to start? You go here on your cluster, on your terminal, and you have to make sure that your Docker is running, and then you run a command called as Minikube. Okay, and say its status. So for me it's running. Let me close it so that I give you some Minikube. Stop. Okay, let me show. Minikube is something which is like officially supported by K8's ecosystem. Kubernetes start. Okay, so Minikube is a local Kubernetes focusing on making it easy to learn and develop for Kubernetes. All you need is a Docker or virtual machine environment. Kubernetes is a single command away. Minikube start. So that's all you need. 2 CPU चाहिए इसको, 2 GB चाहिए, अच्छा चलेगा. इससे कम रखोगे तो नहीं चलेगा ठीक से, ठीक है. So this is something which you need to have. कैसे इंस्टॉलेशन करना है, ऑल दैट इन्फॉर्मेशन इज ऑलरेडी हियर. स्टार्ट कैसे करना है, इंटरेक्ट विद योर क्लस्टर कैसे करना है, इस पे पहला पॉड कैसे इंस्टॉल करना है, वो सारा चीजें यहाँ पर ऑलरेडी है. Don't get confused too much because I will show you. So I will maybe just show you these commands, okay, very quickly. See. So I will go here. Okay, I will go and say Minikube start. When you say Minikube start, it will create this small cluster on your machine. Okay, preparing Kubernetes 1.24.3 on Docker. This is तो Kubernetes को preparation कर रहा है. It's trying to install Kubernetes as a single node instance. तो जो कर रहा है उसको करने देना. Don't interrupt. Let it do. If this gives error, then it mostly primarily could be because of your Docker installation ठीक से नहीं हुआ, या फिर Minikube का कुछ प्रॉब्लम है, पहले आपने चलाया होगा वो नहीं चल रहा है, तो you have to kind of delete it first, right? So Minikube का I think it is a command called as destroy or something, or remove, delete. Okay, so you say delete Minikube, so वो पूरा Minikube delete करेगा, and then you simply say Minikube start again, and then everything should work. मेरे साथ यही हो रहा था when I was running Minikube for your demonstration. When I said it was giving a lot of errors, then I simply deleted it and then started, and everything worked. So this is one solution which you can try if you get an error. Okay, so Minikube status. So it's saying control plane running, host running, kubelet running, API service running, kube config configured. So don't worry too much about it. All these things we'll understand later. But you start with the basics here first. Okay, the basic here says installation you will already do. Okay, if you are on Windows, then it will tell you how to do it. These are like command for Windows. exe download करना सबसे आसान होता है. exe करो वो सब उठा के कर देता है. This is the fastest way. Okay. You create the start the cluster. Okay, fine. Then I'll go here and say kubectl. So kubectl or kubectl also it's called. It's a Kubernetes command line interface. You have to install it. So Kubernetes, to make this command work, you have to install kubectl. So this, I think you will get instruction here. No, don't use this. This is kubectl inside Minikube. Don't do this. Just search for Kubernetes kubectl installation, and then you will get it. Okay, it's not that complicated. So you search for installation of kubectl. Then you install kubectl. Then you will have kubectl command there, and then you can run commands. So when I say kubectl get pods. So I have these 2 pods already running. You know what pods are? These are the pods. If I want to know what's running inside my pod, then I can search it like this. What the hell? Where go? Okay, yeah, here. Okay, so I can see these 2 pods are running. Okay, then if I say kubectl
सर आपका
get,
स्क्रीन है हाँ ठीक है
okay, say kubectl get service. So now you see, this is what I was explaining you. Okay, so you know, you have pods and you have services, and in the service you have types of service. So node port type, cluster IP type, but then all of them will definitely have a cluster IP. So in सबका cluster IP already available है आपके पास यहाँ पर, right? This is cluster IP, this is internal IP, and this 5000 is the port on which the service is running. Okay, let's go back one step. Let's go one step back. Okay, so if I go back, let's just follow this example. Okay, so you have to do just simply follow this example, which is get started guide, deploy application, right? So here they are saying you deploy minikube, right? This is what I have done. So I've said kubectl create deployment, hello minikube, image is this, right? So when I deployed my Flask API, that's what I did. I simply said kubectl create deployment. Okay, हम static site चलाते हैं. Okay, let's start with the static site. You know, we had an image called a static site. Let's go to Docker Hub. In Docker Hub, sign in, continue. Okay, so you see, I have static site. This is what we started with the first, right? So we have this, and there are multiple tags here. Let's see if I go and deploy version 1. Okay, right now if you see, I don't have anything here. So I don't have a service with my static site. I don't have any pod. So if I say pod, I don't have, and I don't have a deployment either. By the way, I haven't told you deployments, which is okay, which is just an abstraction on top of pod. We'll discuss it later. But right now, the 2 most important components is pod and service. Okay, that's what I've explained. So we have pod, we have service. Now, if I want to deploy a new pod, what I will do, let's go back. So this is the command. Okay, let me move this piece here. Okay, so if you want to, so you have to copy this, right? So copy this. I go back, I paste it. No, I don't want to paste all. Okay, let's remove it. This part, let's do one by one. So I'm creating a deployment. Okay, and I'm saying not hello minikube. I'm saying, first of all, I'm saying my static site. My static site, and then what image I want to run, right? So I want to run my static site image, right? So I will give the whole path here, 333743, and I say my static site version 1. Fine. So this is this create deployment is similar to create pod with few more things which we'll discuss later, but it's very similar to pod. So read, I am simply creating a pod here, right? So I'm saying create deployment my static site image is this. I've given the image and I say enter. So it is saying created. Now I say kubectl, then I say get pods. So now it's saying the pod is running. Right, so now the pod is here running. Okay, so my first step is done, which is this one. Second thing is the pod doesn't have anything, right? It does not have any IP linked with it, right? So if I go back here, there is nothing linked here, right? There's no IP, so I want to create a service now. To create a service, I have two commands. Either I say kubectl create service, or I simply say kubectl expose deployment, right? So now I'm going to expose deployment to the node port. If I go back here and I want to deploy, it was Nginx, right? So maybe it is 80 and node port, and I will go here saying my static site. Okay, okay, my static site. Okay, so it has created a service and it's saying it's exposed. So now if I say get service, it is saying my static site is exposed like this. Okay, then I can then try to access it in different ways. Okay, what are the ways? Can anyone tell me what are the ways which we discussed? How we can expose this?
Load balancing,
Okay, do we have
cluster
a
IP, node
cluster
port,
IP? Node port, then
load balance,
Cluster
cluster IP, node port, and load balancing is last.
and node balancing, right?
सर
Huh? Okay.
Here
सर
we
ये
can use node port.
Sorry.
यहाँ पे हम node port use कर सकते हैं ना?
हाँ, कर सकते हैं.
Yes.
Okay, but this node port is the node of a cluster inside Linux, right? So that's the problem, because I'm using Minikube. Minikube runs inside a Docker. Docker runs inside Linux system, Ubuntu system, which I have here, and that's where it's exposed. So I cannot now directly on my machine use this and access it. That's the problem. Okay. So for this, there is one more way I explained, which was port forwarding, which is just used for local access. So port forwarding is a way which is given by Kubernetes itself, so that you can forward any port from your local machine to access any service running inside the cluster. So you can access, even though if it is cluster IP node port, still you can go and access access it using port forward. Okay. Okay, so now the same thing I will try to use here. Okay, I'm tired. Okay, let's wrap up quickly, and then
सर
we'll do. Yeah, go on.
सर ये पोर्ट्स में जैसे 80 के बाद में 31845/TCP है, ये सर ये क्या?
Yeah, this is allocated by Kubernetes. Kubernetes has a port range which it allocates internally. That you access it here, but then it will route it to this port, to this specific. So maybe we'll see more about it later. When we start deploying the applications, then we get to understand more about the ports, how it manages these ports internally. Okay, so we say kubectl port forward. Okay, and then you try to give a name service, my static site. This is the service name, and then I want to say 8088 maybe. Okay, and then if I go and localhost 88. Okay, so my site is now up and running. So this is being accessed from outside to here. So my static site is here. From my local machine, I am accessing the node port, and node port has been tunneled to access the internal container. So there are many ways I told you. One is for port forward. I have explained you. Port forward is something which is used for development purposes. Okay, so we will be using load balancer and ingress later. In actual enterprise setup, this is what is used for local checking, local validation of what is running, how you access this port, because ऐसे तो होगा नहीं access, you have to access via some way. when you are developing. So port forward is primarily what is being used a lot to access what's running inside the container or inside a pod. That is what I have showed you just now. So this is local. मेरा local का port should be redirected to port 80 because that's what I have node port is exposed on port 80. So node port पे 80 पे जाएगा, फिर वो अंदर internal service run हो. My static side is an internal service, right, which is running on 31845. So पूरा chain happens like this. If I close this, it will be closed. Okay. Can I show it here? Why is it coming like this? Okay. So quickly explaining again, just to summarize, I exposed it here. मैंने service बनाया. Service is node port is cluster IP पे है. Cluster IP मैंने node port 80 expose किया है. तो 80 का traffic 31845 नाम की service पे जाएगा. And वो पूरा chain बनेगा वहाँ से. तो मैं 8088 मेरा local है, वो 80 पे जाएगा. 80 route करा 318 पे service redirect करेगा container पे. Container से reply आएगा. That's what was happening. But we will do this case again, maybe with more elaborate examples. Today, I just gave you a small, very minimalist demo of service and pod and all those things. Tomorrow, maybe I will explain with the proper YAML files, deployment files, service manifest files, pod manifest files, and maybe we'll try to deploy our application, the Doctor Everywhere API. Yeah, I'll try to deploy this to show you. Okay. Okay. I don't want to continue more on telling more because I can't. I'm like tired right now. I can't explain more topics, but I can answer questions if you have any. So floor is yours. Okay, how many of you found it very complicated? So everyone found it easy? Okay, no one found it complicated, no one found it easy. Okay, anyone found it in something in the middle?
Yes, sir, it is a bit complicated.
Complicated, huh?
Mm.
Okay. It may be, it may look like complicated, but I think if you try it, it is actually not. The complication is happening somewhere here, but if you understand pod, container, and service, and then that's it, yeah. Then there's nothing much. Of course, there will be more things, but the basic is, I mean, you will get started basically. The primary goal is that you get started playing around with things. Uske baad, धीरे धीरे you can build on it. So yes, in some way it is complicated, but you have to learn it. There is no other option. If you want to be a DevOps engineer, if you don't know Kubernetes, you are not a DevOps engineer. As simple as that. So you have to learn it. The learning curve is a bit steep, I agree, but you can make it simple. So I'm trying to make it simple for you so that you can just do at least some basic stuff. By the time this whole course is over, you will be able to do at least basic deployments on a Kubernetes, existing Kubernetes cluster. That's the objective. I think that much I will be able to teach you. Fine, cool.
ये कोड कंटेनर और सर्विस